Okay, so this will be a practice video. We're going to look at how to determine the mole ratio. So these are just practice problems that we're going to work on in this one video. Okay, so our problem is sample of carbonate rock is mixed with calcium carbonate and magnesium carbonate. The rock is analyzed in a laboratory. So this is an example of a mixture. We were talking about compositions of mixtures in the last video. So the rock is analyzed in a laboratory and the results are recorded in the table below. Calculate the mole ratio of calcium to magnesium in the rock. Okay, so here's the total mass of the sample, 98.5. Here's the mass of carbon, the mass of magnesium, the mass of calcium, um, and then the molar mass of each one of those things. Remember, molar mass is grams per mole. So it's how many grams are in one mole, which is basically just your atomic mass. If you look, that's how they get that off of the periodic table. Um, so then what they're going to do next is they're going to take the mass of magnesium, okay, and find out how many moles of magnesium we have. So remember we said at the very beginning, moles is a way to bridge the gap from grams to moles, or to number of molecules. Okay, so we're going to take 2.4 grams. We're going to divide it by the atomic mass of magnesium, which is 24.3, which gives us the number of moles of being 0.100 moles of magnesium. And then we're going to do the same thing for calcium. So 36.1 grams of calcium divided by 40.1, which again, we just get that off the periodic table, and that gives us zero point 0.9 moles of calcium. And then, since it specifically says the mole ratio of calcium to magnesium, I'm just going to make a ratio of those two numbers. That's all I'm going to do. So zero point 0.9 moles of calcium is going to go on top. That's the first one that's mentioned in our ratio, and zero point 0.1 is going to go on the bottom. So it's a 9-to-1 ratio of calcium to magnesium. That means in that mixture of that rock, I have 9 times more calcium than I do magnesium. So that's an example of composition of a mixture. You have two compounds in there. They are two separate compounds, but they're mixed in varying proportions. And we just found the proportion for that particular sample. Okay. So again, this is all should all be reviewed. And going back to the mole and that concept of the mole being extremely important for going between and converting between the number of particles, the number of atoms, between grams, on all of that is done through that concept of the mole. The molar mass, remember, is just the mass in one mole, and that's found, if you're talking about an element, that's found on the periodic table. If we're talking about a compound, that's found by adding up all of the atomic masses for each atom in that particular compound. Okay? So the next set of slides, we're going to start talking about atomic structure. A lot of this should be reviewed as well, but we'll be getting a little more in depth with some things in this next section. Okay. All right. If you have any questions, make sure you email me or contact me through Schoology, or just bring those questions to class with you and we'll get them answered for you. Okay. Have a great night.